So this is a short video on interpreting error bars on bar graphs, and the important thing to understand is that there are different kinds of error bars and they can lead us to making different kinds of interpretations. In this video we're going to look at three different kinds. I've started with some data. I've collected tens values for each of two different systems, and you can see here in this table the mean of those values. For system 1 the mean is 13.10 and system 2 the mean is 11.0, so there's a difference in the mean. And this column gives us the standard deviation. For system 1 it's going to be 0.57, system 2 0.67, so there's a difference in the standard deviations as well. So what I want to do is look at a graph, bar graph, with error bars to indicate the standard deviations. So here we are, and you can see the error bars here indicating the standard deviation. So this is one standard deviation about the mean. So here's the mean for system 1, and the standard deviation ranges. Lowest value is around there, not quite drawn that very well, highest value is around there, and the mean for system 2 is here. And the standard deviation is just a descriptive measure, so it's an indication of the variance of the data around the mean, so how much the average data point varies from the mean. We can't use this to determine any inferences about the population. It just describes the sample. In order to make inferences about the population, we need to use a different kind of error bar. So this is the same data, but this time we've plotted the standard error, and you can see that the standard error in this is smaller than the standard deviation. That's because the relationship between the standard error in the mean and standard deviation is it's the standard deviation divided by the square root of n, where n is the number of items in the sample. So that means that as n goes up, generally speaking, the standard error will go down. So as we increase the number of items in the sample, we will decrease the standard error in the mean. So what can we tell from the standard error? Well, we can use the standard error sometimes to make inferences about the population, in particular whether the difference in the means, in this case difference between 11 and 13.1, 13.1 minus 11 equals 2.1, whether that difference of 2.1 is statistically significant. I say sometimes. In this particular case the error bars are not telling us anything helpful, and the reason for that is that there's a gap between the lowest of the higher mean and the highest of the lower mean. So this gap here exists, and that tells us that I can't draw any conclusions about the statistical significance. If, however, there had been overlap, so if the intervals had looked something a bit more like this, then there's an overlap between the two, this region here, that would tell us for certain that the difference between the means is not significant. So not particularly what we wanted to look for probably, but it tells us that they're not significant. The reverse, whether something is significant, we can't work that out from the standard error in the mean. And to work out whether the difference is significant, we need to look at a different kind of error bar, which is the confidence interval error bar. So here is the same data, and this time we're plotting the confidence intervals. You'll notice in this case that the width of the confidence interval is greater than the width of the standard error. That depends on the distribution statistic that we're using. In this case it's a critical t value, and what you'll notice about this particular distribution this time there is a gap between the two confidence intervals. And if there's a gap between the confidence intervals, that means there is a statistically significant difference. So the confidence interval has led us to conclude that there's a significant difference in this particular case between the means of the two systems. So this is the same as calculating the probability value and finding that the p-value is less than 0.05. In this case it's 0.05 because we're using a confidence interval of 95%. 95% confidence interval means 5% in the p-value, 0.05, since p-values range between 0 and 1. So you can use the confidence interval error bars to draw conclusions about something being significant. You can use the standard error to draw conclusions about something not being significant, and you can't draw any conclusions by using the standard deviation because it is not a mechanism for inferring things about the population. It merely describes the variation of data within the sample that you chose.